In machine learning, there's a lot of statistics, and you'll probably come across R squared at some point. And so I'm making this video to try and clarify what it is. So I guess it's worth mentioning that R is actually correlation. For those of you who are familiar with that, in correlation, if you have a positive value, so correlation ranges from -1 to 1, and if it's -1, that means that two variables are negative correlated, and what that implies is as the value of x increases, well then the value of y will decrease. And if you have a correlation of 1, then when the value of x increases, the value of y will decrease. And if you have a correlation of 0, it means that x and y are unrelated. So it doesn't really matter what value you have for x. Y will be something, it'll be independent, so it could be whatever it wants. And the reason why we use R squared is because it tends to be easier to interpret, especially when it comes to comparing different values. And so right here we plotted the relationship between the salary and years of experience, and as we know, they tend to be positively correlated. So the more years of experience you have, you tend to have a higher salary. And so if I were to draw a line right here, let's say this is our mean. So the mean is the average, so we take the sum of all the different salaries and then we divide it by the total number of samples. Here we have 8 data samples, each of these representing a person. And if I drew a line, oh, that's really bad. If I drew a line going from all the data points to the mean, this is the variance. Okay, and the variance of the data set is the sum of all the data points. So let's call this PI for persons minus mean, and we square that. The reason why we square it is because for all the data points below the mean, we don't want those to cancel out with the data points above the mean. And a really important fact about means is that, let's say I drew another graph for salary, but this time, instead of looking at the person's years of experience, let's say we look at their height, and we try to map the relationship between salary and height. Well, again, the salary, you should end up having the similar data points, but they don't have the same x coordinates. But again, if I drew the mean here, it would be the same. And where R squared comes into play is when we try to determine the best fitting line. So let's say we use linear regression on this data set, and so we would draw a line similar to this, and again we would calculate the mean to that line, or the variance. So I don't know how difficult this is going to be to see. Yeah, you guys won't be able to see that. Okay, let's try something different here. Let's try that. Okay, so you end up drawing lines from the different data points, but this time to the best fitting line that we determined during linear regression, and that's going to be equal to the variance of the line. And so this right here is the variance of the mean. And r squared is going to be equal to the variance of the mean minus the variance of the line over the variance of the mean. And so because we divide it by the variance of the mean, we're going to get a number from 0 to 1, so it's going to be a percentage. And let me make more room here. Ooh, that's bad, but it should be good enough. All right, so suppose that we calculated the variance of the mean to be, let's say, 500. And then the variance of the line, because it fits our data better, is going to be smaller. And so let's say we determine the variance using this formula. So for the variance of the line, it would be the exact same thing. But instead of using the mean, we use the line at that point. And we take the square. And so let's say we calculate it to be 20. Using this formula right here, we get r squared is equal to 500 minus 20 over 500. And that gives us 0.96 or 96%. And what this number means is that 96% of the variance can be accounted for by the years of experience. And so whenever you're building machine learning models, well, this would be a really good feature to have because it accounts for a substantial portion of the variance for our labeled data.